Hello, my name is Victor Lopez, and I'm making a series of videos in which I work on Python.cards. Python.cards is this project I started some time ago, which aims to help you learn Python via spaced repetition learning. That is, via some flashcards that you can review. You can see it here. You review the card, then you say if it was easy, hard, or good, and then you will get the same cards repeated at longer intervals of time. So I'm starting to create some decks. I started yesterday with the pathlib standard library module. If you don't know pathlib, this is a module for managing paths, like splitting paths, modifying paths, and also handling the files that those paths point to. This was it was added in Python 3.4, that is about the year 2014, but it's not very well known, I think, because there are alternatives. If you have used the classic way was os.path was the model that you would use for this kind of things. But it is a very, very useful library. So yesterday we created a bunch of cards, and I've been reviewing the documentation, thinking of more cards to add. Still, we didn't go through all of it. So let's continue today adding some more cards. For now, I'm just adding them into a markdown file, and then one day, sooner than later, I will write this script that processes this markdown file and adds it to the Django app, which is how Python.cards is built. It's a Django app. So today, I'm going to add some cards like in the middle of what we did yesterday, because I thought that there are some things that we could improve. And then we're going to continue. Yesterday I left a to-do, so this as POSIX, this is where we left it yesterday. We're going to go through all of the API, and then we'll see once we have added the whole API, what else we can improve. One thing to note is that for now I'm adding like cards for everything, right? In the future, or once we have this deck complete, I'm going to add some tags or some other metadata information about each card. For example, I don't think all of these functions are as important. Let's check one. For example, there is one called isJunction, which is, I didn't know what a junction was until I read this documentation. So a junction is kind of a concept in Windows similar to links, but not exactly the same. This is a pretty niche topic, and I don't think it is very important. On the other hand, there are others, like for example, walk is very useful, and there's others. For example, read text or write text. These are very handy operations because they allow you to write a whole file or read a whole file as texts or as bytes with one single function call, compared to the normal way of doing this, which would be opening a file and reading the contents, and you need to do that into a with a block, so the file is closed after reading. So read text or write text is a very common and very useful. And then there are others. For example, resolve is very, very important, because resolve maps a path to like the real file in the file system, and it removes all of the to an absolute path. So it removes all these dot different traversals. It resolves links and so on. So if we need to compare, resolve is a very important function. Unlink, for example, which is for deleting a file, is very important. On the other hand, isJunction, or even this lchmod, which modifies the permissions of a file for a link. So if it's a link, it modifies the link and not the file that it is pointed. In my opinion, these are not that important. So we'll add this kind of tags. So I think when you're learning, in this case pathlib, but also other decks in the future on Python.cards, not every single card has the same importance. So I would say there are some must-knows. So there are some things that you should know if you are a Python developer. Some others are nice to have. nice to know, and some are really kind of obscure things that if you know it's better, of course, but they are not that important, right? Same thing would apply for his FIFO, so first in, first out. This is not very common. You would rarely use this kind of things, but it's good to know that this exists. Okay, so what did I want to modify from what we did yesterday? So one thing with cards is that you don't need to be like very minimal when you create the cards. What I mean, you can be redundant. You can have different cards that ask for the same information. That is no problem at all, and that is interesting. That is because it is useful to, let's say, access the same information in your memory from different places. You don't need to see it from a single place, and that way you already know it, and you don't need to learn it anymore, right? So what I was thinking, for example, is of the suffixes function. So here we said, how can you find the list of a path's file extensions? And you use suffixes. But at the same time, we could have pathlib suffixes output. And of course, we will not have these two cards one after the other. Okay, so we will not write this. We will not present the user these cards one next to the other. We might present one day and the other another day, right? But we would say, what is the output of the following code snippet or code? Also, sorry. Another thing I thought is that I want to modify all of these snippets to import these things. You might think that by not importing this, we make them shorter and you already can understand them, but I want to have in the future some kind of validation to actually run this code and then check that the output is what we have here in this card. So it's useful to import the path every time, so then we can do this validation. So that's something that I will also modify in the cards that we are working on. So what is the output of the following code? So we could have this. We could have a different file extension. What file extension could we have that has two suffixes? I like, if you don't know Z standard, this is a very interesting compression format. So what would that be? ZST dot or tar dot ZST. That's something that would be the okay, yeah, the tar dot ZST, for example. This Z standard, there's an interview. Is it in co-recursive? Yeah. There's this interview which I recommend very, very, very much. It's very, very interesting how this guy started to work on compression and obsessively working through compression and getting better and better and better and better. And then he ended up creating Z standard, which when I learned about it, I thought it was like a Facebook thing. But it turns out he joined Facebook after creating the algorithm or the method. So it's not like Facebook invented this. It's this guy who invented this, which is kind of a better, it has better compression than gzip, but not only better compression, better speed, so it's overall better, right? So here we have this ZST. What is the output of this following code? And of course, this one is what we want to hide. So, and we don't want to hide the suffixes. So this is one card that I wanted to add. We can add some other files, some other kind of these questions. Another thing that we are seeing a lot here, we added this Windows UNC. So what is the UNC? Another thing would be nomenclature POSIX. So what is POSIX? This is an interesting question. What does POSIX mean? We are seeing POSIX all the time, right? So pure POSIX path and all these things, or POSIX path and all these things. So what is POSIX? You will probably, maybe you already know the answer, or maybe you think, so I'm seeing the Spanish, the English, and the Catalan Wikipedia. Okay, so POSIX stands for Portable Operating System Interface. So what this means is that if you know about POSIX, you will think that probably Linux or Unix or even macOS kind of means POSIX, right? So this is a standard that was created. This is a family of standards specified by a society. Let's link to this page here. It is a family of standards that defines system and user level APIs, command line shells, utility. Oh my god. It's hard to explain. You would think about it, it's like they took the Unix more or less interface and they standardized it. So if you want to have some POSIX compatible things like a shell, like bash or other things, or utilities, like I think there's like CP for copying, ls for listing the directories, and all of this is standardized. It's a family of standards that defines user level APIs, command line shells, and utility interfaces for software compatible with variants of Unix. Let's keep it like this. So let's see. Is macOS POSIX? I don't know. Yeah, it is a POSIX. Linux, I guess also like BSD, like FreeBSD, OpenBSD, and so on. Operating systems such as Linux, Mac OS, FreeBSD, and FreeBSD are POSIX. Oh my god, compliant. Okay. So that way we know what POSIX means, because otherwise we are a bit lost, right? Let's continue with the asPOSIX. We could also, we are talking about paths a lot. So what is we could check the os module. So if we go to the os module, os.name. os.name, sys.platform. I think os.name. The name of the operating system dependent module imported. The following names have currently been registered: POSIX, NT, Java. So pose name. How do you know if a well, let's keep it for another time. But we have this separator also. So ossep. What ossep Windows? What is the separator? The path name separator on Windows. Okay, no, that's a problem. So what's the path name separator? It is this thing here and can be found on os.sep. Okay. And then on POSIX. What is the path name separator on a POSIX operating system? It is a / and can be found on os.sep. Okay, that's another thing that would be helpful to learn. So one day we will be learning the OS module and we will know more about all of these operating system specific features. So we were as POSIX. Right? This is the kind of thing that I don't think is very important, but let's go for it. So pathlib as POSIX. How can you represent a Windows path with forward slashes? So you would do it this way. Python. You need to import some stuff from pathlib. Import pure Windows path. So that's how you do it. And the same as pathlib as URI. And now, again, what is a URI? Nomenclature URI. What does URI mean? So URI, if we check this thing, but instead of Catalan, we look for that in Spanish, in English. URI stands for Uniform Resource Identifier. You might think of you might have heard of a URL, right? I think the URL is a kind of a URI. So URI is kind of more general than URL. URI versus URL. Probably there's an image. So yeah, a URI can have a URL or a URN. It kind of, okay, it's an identifier. Let's see what are file URI scheme. Okay, let's go back to URI. Syntax. Scheme. Okay, let's link to the Wikipedia in case someone wants to know more about what the URI is. For now, it's important to know Oh, sorry. For now, it's important to know at least more or less what it stands for. URI stands for Uniform Resource Identifier. It is a kind of unique sequence of characters used to identify some resource. It follows the it is formatted as this thing here. Text, this thing here. Okay, so what does URI mean, this thing? And then how pathlib URI file. What is the format of a URI? What is the URI format of a file, right? It would be this thing here. Well, let's forget about this. We will have this question in two ways. How do you get the URI of a file path? That's a question. So here you will have this Python from pathlib import your path or pure POSIX path. So we have this thing, pure POSIX path, pure Windows path, and we would have this thing here. Oh, I forgot to add this thing here. So here we have this import PS URI, and the as URI is the thing that we could hide the whole line. Okay. So the question is, we could also have pathlib as URI out. So what is the output of this code? And we're going to add only the POSIX case, okay? So no need to have, we are missing something. Okay. And here too. So we are going to add only the POSIX case because the other one is equivalent. Okay, so we have the POSIX, as URI output. Let's go for is absolute. Pathlib is absolute. So as I mentioned before, we're going to add all of the functions in the API, in the pathlib API. And then we're going to, later on, we're going to categorize them into which ones are more important, less important, and also the order, right? We don't want to have these two questions, which more or less ask you the same, in the same order. We will order this. And this is another thing that is interesting, which is that I'm working on some, so the cards will have like a feedback feature. So you will have like a thumbs up, thumbs down button. You can also add a comment, and maybe I will also add some kind of feedback of how difficult or useful you find some question. Maybe the thumbs up and thumbs down is enough. But I think that's important because if I get this feedback of users of what cards are harder or they like it or like they are well stated and so on, or even some comments of if there's a typo, if there's something missing, if something is wrong and so on. If I get all of this feedback, it will be very helpful for improving the deck of cards. Okay, so is absolute. That's where we are. Whether a path is absolute or not. So this one is absolute, this one is not. how can you know if a path is absolute or starts from the root, right? If a path starts from the root. I don't want to put the word absolute because otherwise it's very obvious what you need to do. So this is Python from pathlib for pure Python. Sorry, POSIX path. True. Let's split this thing. This way, we don't give away that this is a method for this function. So I think we don't need like a back for this card because we already have this thing. So is absolute Windows output. We can, what is the output of this code? So we can do a similar thing. So this is the weird thing here is this one, right? Is it absolute? No, because you need to add the drive. So we would have this. What is the output of the following code? So it is pure Windows path. Windows path /AB false, right? And now we do need to add some kind of explanation. The Windows path /A/B is not absolute because it doesn't include the drive. The following. So C:/SB would be absolute. For example, in contrast would be absolute. Okay, so we have this snippet of information, right? That you need in Windows, you need the drive. We have this stuff here, also the UNC. Let's say Windows missing drive output. So let's call this pathlib Windows UNC output. So what is UNC? If you remember from yesterday, we decided that UNC is this unified universal naming convention. Okay. So the UNC is // some share true. Some share is absolute because it refers to a UNC. What was it? That universal naming convention. So Windows UNC. Let's copy this link again. Okay, so this guy here, it's in Spanish. Can we make it in English easily? And US. Okay. It's a UNC share. Let's link this stuff here. Okay. Whatever. So we covered the is absolute. Let's continue. Let's see how many we have left of the pure paths. Do we see the end of the pure paths? Okay, we almost see it. Hopefully we can finish with the pure paths today. So let's look at the is relative to. So pathlib is relative. If you realize we are following lexicographical order, right? Alphabetical order. So this is relative, it's reserved, and joint path. J goes after I, and so on. So is relative to. How can you check if a file path is, you could say relative or child, right? Is a child of another one, right? So for example, you have this Python snippet where you from pathlib import your path, and you do this thing here where you, so p equals pure path of /etc/password. It's interesting that the Python example has the single quotes, and now it's become commonplace to use the black formatter, which has double quotes. So is this relative to etc? Yes. Is it relative to user? No. So is relative to etc. We could even say, yeah, let's keep it this way. So is relative to etc is relative to user. I don't think there's much more to this function. This is what it is. There's this thing of additional parameters. It was added, it was deprecated, so we forget about it. Is reserved. This is another Python thing, right? Pathlib is reserved. How can you check if a file path is reserved? Okay, now these two cards that I'm going to add, they should be in order, right? So this one is reserved, apparently. So from pathlib import pure Windows path. Is reserved. And the output says pathlib is reserved POSIX. What does is reserved return if P is a pure POSIX path? It always returns false because there is not a reserved, right? There's not a concept of reserved file paths in POSIX operating systems. Okay, so that we have, and let's finish this one here. How can you check if a file path is reserved? With is reserved. File system calls on reserved paths on Windows can fail. Let's copy this thing, right? Fail mysteriously or have unintended effects. Okay. Cool. We could copy this stuff here. We could also link to all of this documentation. But I don't know. It's not necessary. Okay, so let's join path. Let's join the path. Calling this method is equivalent to combining the path with each of the given path segments in turn. So pathlib join path. So this is interesting, for example, that you might think is join underscore path. So this is one of these things that you might get wrong if you don't remember the right syntax, right? Because we have is reserved, has an underscore in the middle, join path doesn't have, for whatever reason. So join path pure POSIX path. You can either join a string or a POSIX path or a list of strings. I think the interesting thing here is this one here, right? So you would want to use the slash operator generally for doing this, but so how can you you're appending, right? You append can you join so this is an example of thing that I don't think is very useful. So how can you join list, or how can you append some path segments to an existing path? Something like that. So you would, from pathlib, import pure POSIX path, for example. You would do so you would do pure POSIX path /etc makes sense. And you would join path, right? Init.d, let's use nginx instead of Apache, or let's say nginx /conf.d. Is it conf.d? etc nginx. I don't have it. I think conf.d exists. So, and then you would get this pure POSIX path that has /etc nginx /conf.d. Right? So how do you join this path? With this. I think you can get like the exact equivalent thing of using slashes, right? So if you do this and you do this, you have this. Well, if we remove this special syntax, join path, if you do slash nginx slash conf.d, you would get the same thing. The same thing can be accomplished with which I like better, honestly. But okay, it's good to know that both things exist because you are sometimes working with someone else's code and you might want to know that this exists or modify it or whatever. So okay, let's put the whole example here and then you get the same output. In fact, the output you get is with a single quote. So when we parse this output and we check that this matches, we will get the single quoted version. Okay. So we got the join path, which I think is not very useful. Now match. Now match is important. Then relative to, with name, with stem, with suffix, with segments. I think, man, because these are easy, let's have the with name. Right? Let's have the with name, which will be easy, and then we go back to match and relative to, which are bigger functions. So with name, return a new path with the name changed. How can you modify? It's not modify, right? How can you get a new path with the name of the file? Is it the file or is it also the directory? We already said that the name is the final path component. So if it's a file, so if it's a pure POSIX path of etc.name, this is etc, right? How can you get a new path with the name, with the last component modified? So from pathlib import pure path or pure POSIX path, right? What happens if you okay, that's interesting. So that's interesting. So pathlib instantiate pure path. What is the output of the following code? So from pathlib import pure path, and it says this thing here. And this is what we hide. In a POSIX operating system, you get a pure POSIX path pointing to the current working directory. Okay, that's another interesting word, right? So nomenclature CWD. What does CWD usually mean? Sorry. Wait. CWD is the current working directory. Okay, let's find current working directory Python. Okay, so what is the current? I mean, the current working directory is wherever you are running the script from, right? So git get cvd contain an absolute path that is current of the calling process. Okay, it's the current working directory from which the process was started. Something like that. So when we instantiate a prior path to the current working directory, if running on Windows, you would get a pure Windows path. Is this a like abstract? Are these abstract classes? Not exactly. Okay. So how can you get a new path? What happens if I import pure POSIX path and do a pure POSIX path? Okay, it points. And what if I import a pure Windows path and then instantiate a pure Windows path? Okay. So here what we added, pathlib, instantiate pure path output. So instantiate pure path Windows output. Where does a pure Windows, what path does a pure Windows path point to if it is instantiated without any parameter? So pure Windows path, pure Windows path, pure Windows path. It points to the current working directory. Okay, what if we dot resolve? Of course, this will not work because it doesn't have a path.resolve. Okay, that's interesting. We will work on resolve later with concrete paths. So these are concrete paths. These are paths that actually point to the file system in your computer, right? So we were with name. So how can you get a new path with the last component modified? So imagine we are here. Imagine we have this. What example could we use? One that makes sense, right? I don't think this one makes so much sense. So let's say if it's a zip file, we could. So let's have this thing. P equals pure POSIX path of, home, or let's say downloads / file.zip. And then we do this thing where we say p dot with name file.txt. But we don't want to change only the suffix, right? Because if we change only the suffix, then we don't have what we want. So let's have, what can we have? File.zip. what kind of change makes sense? We want to have file in the same directory, right? So here we could say downloads project main.py, and we want to call it, input.txt. And the output is, let's copy this and make sure we get the right output, because it will be, as far as I know, it will be a pure POSIX path, right? So it will be this thing here. Okay, so with name this. And how do we let's hide this. The method with name replaces the name of the last component of the path. Okay, even would remove this thing. Okay, so pathlib with stem, and we want to change only the so here with stem final or with stem lib. Okay, now this is important, because if there are two suffixes, we're changing the whole suffix. So we can copy this card. So here we'll have two different cards here. So we are changing only the sample with stem. And now let's say pathlib with stem output. So okay, so if we do with stem data whatever new data, this is what you get. With stem modifies all of the file name except for the last suffix or extension. Okay. If it doesn't have a name, it fails. So if you have P is empty, it has a value error. Okay. Do we want to have a card for this value error? Maybe yes, maybe not. I'm not sure. Do we want to have it or not? I'm not sure. Maybe we will not have it for now. Okay, so pathlib, not pathlib. So pathlib, we're growing our list of cards. So pathlib with suffix. So with suffix, you are just changing the suffix. And by suffix, we mean only the last suffix, right? So how can you get a modified path with a different file extension? So we use a pure POSIX path. And now we could say, you know, whatever, pathlib. Let's use a pure Windows path in this case. So you have this file here with suffix txt. Let's hide this thing. And then you have this thing here. So with suffix doesn't have much more. And now with segments, what does this mean? So you have a path. Create a new path object of the same type by combining the given path segments. This method is called whenever a derivative path is created, such as from parent or relative to. Okay, now this is weird. And this is new in version 3.12. So a new path of the same type, so pure POSIX path, by combining the given path segments. This method is called whenever a derivative path is created, such as from parent and relative to. For example, my path etc session ID 42. So you have a pure POSIX path subclass. You store this session ID, and then when you join this thing, the new path keeps the same session ID, right? Honestly, I think this is too obscure. I mean, it makes sense, right? So the thing that we're doing here is we have this path, which is this my path is a subclass of the pure POSIX path, right? So you have the session ID that you added 42. So when you join the path, but still it doesn't call the parent or the relative to. So pretty weird. Python 3.12. Let's find the logic behind this thing here. Add support for subclassing pure path and path, plus the POSIX and Windows specific variants. Subclasses may override with segments method to pass information between path instances. Okay. Create a new path object of the same type by combining the given path segments. Okay. So the interesting thing here is this one here. You are using this, you're sending this information. Let's have a card for this, right? So this will be different, like Ninja 11 Python card. So pathlib with segments. What method should you implement if you want to subclass a pure path, a pure POSIX path, or a pure Windows path? So the answer is pure path dot with segments. This function creates a new path of the same type by combining the different path segments. So this is the idea, right? For example, and let's copy this example here. For example, if you want to attach a session ID to each path and want to keep this session ID when creating derivative paths, such as joining from calling a parent or getting the parent, you can implement it as this. So let's copy the example basically. So here, what you would do, what this does is, I mean, I have already commented this, but let's go through it once again, okay? So you have my path, which is a subclass you're creating of a pure POSIX path. And this has an init function that can be built from a list of path segments, so the arguments, plus a session ID. So you get this list of paths, and then you get the session ID. So now etc has this session ID, which is 42. But now if you add some append or join some other path, or if you get the parent of etc and so on, you want this my path to keep the session ID. So then you have this with segments that is called by all the other, like the pure POSIX path calls this function, and here you create the new kind of my path object with the path segments that are sent, and this will be called when calling parent or when joining and so on. And then you keep the session ID. So when you create this new object, you are passing the same self.session ID that you have in your current instance of the object. So that's the idea. Okay, it's a bit obscure, but if you're doing some like advanced stuff with paths and so on, you might want to have this. Okay, so we only have two functions left for the pure paths. Then we have to go to the concrete paths. That will be another day. The concrete paths have all of these methods for getting the current working directory, the home, and then all of these other things like changing, creating files, reading, writing, resolving like a real directory, handling links, deleting files. So we'll probably devote, I think, 2 videos. So right now I plan, this is the second video we do on pathlib, and this will be on pure paths. Then we'll have 2 more, I guess, on the concrete paths. And then we'll have at least 1 or 2 videos of cleaning up the whole deck, adding stuff, modifying, fixing bugs, loading it to the database, and all of that stuff. So I think at least 4 more sessions, excluding today's, until we have this deck ready. Okay, so we skipped a couple functions, and they are relative to and match. So let's check what match is. This is match is for matching a path with a pattern, and the pattern is the kind of glob pattern. If you don't know what globbing is, you will soon find out. So this path matches this globbing, this asterisk here. These are not like really regular expressions. This is like anything.py. I guess you also have. So let's pure path, abc file.txt dot match. Does this match slash file.txt? True. Does it match this thing? 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 True. Okay. False. So match this path against a provided glob style pattern. Return true if matching is successful. Okay, so pathlib match. But there's more to this, right? If the pattern is absolute, the path must be if the pattern is absolute. So if the pattern is like this, it's false. If it is like this, it's false. But if it is like this, oh, it's false too. Interesting. So we wouldn't have this kind of recursive thing. And that is true. Okay. Interesting. If pattern is relative, the path can be either relative or absolute. Matching is done from the right. If pattern is absolute and the whole path must match. The pattern may be another path object. This speeds up matching the same pattern against multiple files. This speeds up. This is interesting, the speed up. This is interesting. We might want to check there's this time it thing. So let's time it, right? So if we time it, we time what? So if we time this thing. So if we time it, so the pattern, if the pattern is this, and we want to match this thing, so what is the lambda? The lambda is this thing here. We match this thing. Time it. Okay, we did it a million times. So if we match this, this is how long it takes. If we are matching against slash against this thing. If instead of matching the string, we match the pattern, what happened? Pattern pure path is match pattern. There's a type error. Oh, because this was changed in version 3.12. That's interesting. So pyenv local 3.12. Pyenv install 3.12. Let's use 3.12 and see if this is solved, because this is an interesting problem. Anyway, I'll have to get going now, so let's leave this for another day. Next day we will continue. So to do pathlib match, to do pathlib relative to. These are the two things that we have left to do. We will test this thing on Python 3.12. We will test this thing, and we will continue with this. As I said, we will finish these two pure paths functions, the match and the relative to. We'll talk a little bit about globbing, which is used on the match thing. And then we'll move to concrete paths. So concrete paths actually modify the files in the operating system, in the file system. So we will create files, read files, check the size of files, modify files, delete them, link them, and all this stuff. Okay, see you next day, and hope you're well.